Hi Math 111. In this video I just wanted to go over an example from your textbook with you. This is from section 2.2 and it talks about how we can make use of a graph of a function to get some information about the graph. So let's see, make sure my pen's not too big here. So again, this is in section 2.2. Okay, and this is on page 75 and we're working problem number 10. And you can see that I have the problem over here on the left side here for you to see in case you don't have your textbook there with you. Okay, so this blue thing right here, that's the graph of the function, right? And it is a function because if you notice, if you look at any vertical line here, as you look along the function here, along the graph, all vertical lines only hit the graph one time, which means that we are in fact looking at a function. So let's work through all these letters of tasks here for us to do. So let's look at part A. Okay, so we're asked to find f of 0 and f of 6. Well, remember this notation here is asking for the output of the function when the input is 0, right? So let's see. If we look at the graph here, remember the graph is the collection of all of the points that work for the function, the inputs and the outputs, right? So if a point is on the graph, that means that the input would be, for example, here at negative 2, 1. That point is on the graph, so the input is negative 2, the output of the function is 1. Right? So if we're asked for f of 0, I just have to look for when x is equal to 0, where are we on the graph? When x is 0, we are right here, right? So notice that point 0, 0 is on the graph, which means when the input is 0, the output is 0. Okay, so that means that f of 0 is 0. Okay, and then when I have the next question here, which is f of 6, right? That's asking for what is the output when the input is 6. So when the input is 6, let's see, that's when x is 6. My dot is right there. So that means the ordered pair 6, 0 is on the graph. Input is 6, output is 0. So f of 6 is also 0. Okay, let's go to part B. So we're asked to find two more values of the function, f of 2 and f of negative 2. Same thing, so f of 2, where is, let's see, there's x equals 2, where am I on the graph? Right there, right? So that means when the input is 2, the output is negative 2. F of 2 is negative 2. And let's do f of negative 2. When the input is negative 2, the output is, where are we? There we go, that dot's on the graph. Negative 2 corresponds to 1. So f of negative 2 is 1, right there. Okay. Question 3, is f of 3 positive or negative? Okay, so this is part C here. F of 3, remember that's the output of the function when the input is 3. So let's go to where the input would be 3. That would be here between 2 and 4. Okay, the output of the function would be what? The y value that the graph produces there. So notice that would be like right there, right? If you see my little arrowhead right there. That little point where my arrowhead is touching right there, that would be the point 3 comma something. There would be a number, right? But is that value, that y value there, positive or negative? Well, because we just went down to get to that point, that means that that y value would actually be negative, okay? So f of 3 is actually negative. Okay, and if you wanted to write that as like this, f of 3 is less than 0, right? That means f of 3 is negative, it's less than 0. Okay, what about f of negative 1? Well, let's go to the input negative 1. Where would b be on the graph? We would be right there, right? That would be the point negative 1 comma something, but notice we moved up above the x-axis to get to that point on the graph, which means f of negative 1 is positive. Okay, good. Let's keep going. E. Okay, for what values of x is f of x equal to 0? Okay, so notice this is asking us for what are the x values, what are the inputs need to be so that the output is 0, right? The output, remember, is our y value. Okay, so where on the graph do we have y values that are 0? Well, remember, y values are 0 if we're on the x-axis, right? All points on the x-axis have y coordinate 0, right? So are there any points on the x-axis that are on the graph of the function? Well, right here at the origin is 1. Here's another at 4, 0, and here's another at 6, 0. Notice the y-coordinate in all of those points is 0, right? So if you're thinking about what are the x values that you can plug in so that the output is 0, well, that's the x value of 0, the x value of 4, and the x value of 6. So we could write 0, comma, 4, comma, 6. Okay? Great. Next question, for what values of x is f of x less than 0? Okay, so what inputs do you need to do so that the output of the function is a negative number? That's really what this is saying, right? What inputs give negative outputs? So negative outputs mean negative y values. When I look at the graph here, the graph is below the x-axis, right? Its outputs are below the x-axis right in here. This little arc part right here, right? Okay, those are all the places on the graph where the y value would be negative, right? And so what are the x values that give me those points? Well, if x is anything between 0 and, let's see, 4. If x is between 0 and 4, anything in there, any x value between 0 or 4, when you plug it into the function f, will output a negative number. Okay? So how do I write that? Okay, what values of x is f of x less than 0? Well, x has to be between 0 and 4. Okay, between 0 and 4 for x values, the outputs will be negative numbers. And notice it says strictly less than 0, right? So I don't want to include when is it equal to 0. We already know that. That's a part E. Okay. Okay, part G. What is the domain of the function? Okay, well, remember the domain is just all the x's that you can plug in that have corresponding output values, right? Okay, so if we look at our graph here, right, notice our graph starts over here on this left dot and then it swoops down and comes back up, right? But it says there's a value for the function if x is negative 4, and there's values for all these values of x, right, through here and all the way up to 6, right? And after that, there's no graph, right? If you choose 7, there's no output. There's no dot above 7 somewhere where it says what the output would be. Okay, so that's sort of one way to think about it. Another way to think about it in terms of figuring out the domain is to imagine shining a light above and below the function, like sort of from each side. Shine a light down and shine a light up. And wherever there would be a shadow on the x-axis, that's what your domain is. Okay, and so for us, if we were to shine a light from above and from below, we would get a shadowing where? Negative 4 would be shadowed, and everything here would be shadowed by the light above, and then the light below would shadow everything between here and here, between 0 and 4, and the light above would shadow everything from 4 to 6. Okay, so the shadow would be from negative 4 to 6, including negative 4 and 6, so that's our domain. So negative 4 to 6. Okay, again, that's done by shadowing from the top and from the bottom. Okay, for part H here, to do the range, we can do something similar, except instead of shining from above and below, we can shine from left and right. Okay, so imagine shining a light from the left and from the right. Okay, to figure out the domain, you just have to look to see where would the shadow be on the y-axis. Okay, and that would tell us what y values we can possibly get out of this function. So shining a light from the right and from the left, we notice that this lower curve here would shadow all the way down to negative 2, and then all this middle stuff would shadow stuff from negative 2 all the way up to, let's see, what's the highest point here? The highest point is when your y value is 3 here, right? That would shadow up to 3, but there would be no shadow above 3. Okay, so that means that our range here is from negative 2 all the way up to 3, right? And that's where we stop for the range. Okay, and those are intervals, right? And it includes the endpoints because the endpoints would create shadows themselves too. Okay, the negative 2 would be covered up and the 3 would be covered up here, right? And again, the range is just what all the possible output values that the function is capable of giving you, right? It can give you anything between negative 2 and 3, right? There are x values that can produce any y value between negative 2 and 3. Okay, let's get a new sheet. We're on I now. This is a good example to run through because it covers ideas of domain, range, intercepts, inequalities, all that kind of stuff. So speaking of intercepts, let's find the x-intercepts. Remember, that's where it hits the x-axis here. Well, it hits the x-axis here at the origin, at 4, and at 6. Okay, so for x-intercepts, we have, I'm going to write them as ordered pairs, 0, 0, 4, 0, and 6, 0. Good. Notice that these x values here of 0, 4, and 6, those are the same answers from part E, right? Okay, and that's because you're asking the same question, right? What are the x-intercepts is the same question as when does the function equal 0? Okay, good. Part J. Let's see, for part J, what is the y-intercept? Okay, well, the y-intercept, remember, is where the graph hits the y-axis. That only happens in one place. Otherwise, it won't be a function, right? If there's two y-intercepts, it can't be a function. So here we only have one answer, and that happens at the origin. Okay, Moving on to K, we're almost there. How often does the line y equal -1 intersect the graph? Okay, well, where is the line y equals -1? That would be sort of going across like this, right? Yes, y equals -1 is a horizontal line, right? It's the line which is 1 unit below the x-axis. So if I were to think about this line sort of coming across like this, I wish I had a tool that allowed me to draw in the textbook online. If I imagine a horizontal line coming across like this, I notice that it would hit in two places, right? It would hit at these two places, whatever those might be. I don't know what they are, but it would hit in two places. Okay, so it says how often does it intersect? Twice. Okay, right there approximately, and right there, because that would be where if you hit a y equals -1 line, it would hit twice. Okay, what about the line x equals 1? Well, what kind of a line is x equals 1? X equals 1 is the line where all the x coordinates are 1. It's a vertical line, right? That would be the line that would pass through here, pass through 1 and go vertically up and down, right? Well, because this is a function and x equals 1 is a vertical line, it's only going to hit it once. Okay, that's a requirement for being a function, is any vertical line hits it just one time. Okay, so it can't be a function and have it hit twice, okay, if it's a vertical line. Okay, so the answer to L is going to be just once. For M, for what value of x does f of x equal 3? Okay, so now we're asking what is the input that gives an output of 3? Well, let's see. Let's look along the graph here. Let's see. Output of 3 is a y value of 3, right? So a y value of 3 is up here, right? We want our function to be like somewhere up here. Ah, wait a minute. If you notice here, the height of the function, right, the y value of the function is way up here at 3, right here. Yeah, so what does the input need to be so the output is 3? Well, it's written as an ordered pair. If the input is 5, the output is 3. Okay, so if x is equal to 5, then the output is 3. Or you can write that as f of 5 equals 3. Remember, input is 5, output is 3. Okay, let's try that one more time just for this last one. For what value of x does f of x equal -2? Okay, so again, where is -2 on our, that's an output. -2 is a y value way down here, right? Let's look, scan left to right. Where is the function going down low enough to hit -2? Whoa, right there, right? If you sort of scan left to right here, you can see all the places where the function would output a -2, right? And that would be just one time right here. Okay, so what does the input need to be so the output is -2? That ordered pair tells you. Input is 2, output is -2. So rewriting that point living on the function would be like this, right? You say f of 2 equals -2. Okay, good. Excellent. So that's example number 10 from section 2.2. That should answer some of your questions about how to find domain and range from a graph, as well as finding some values of functions and some other fun stuff. Okay, on to the video for 2.3.